Hey, I love this question. We're going to work out the first three non-zero terms in the Maclaurin series for cosh x to the power of n. First up, we're asked to show the second derivative is given by this. Well, let's work out the first derivative. For this, we use the chain rule, because essentially we've got cosh x all to the n. So I've got something to the power of n. Let's deal with that. Let's deal with the outside. We're going to get n cosh x to the n minus 1. And then we times by the derivative of the inside. Derivative of cosh is sine, or sine hyperbolic x. Can't really tidy it up that much. I might just write it as n sine hyperbolic x cosh n minus 1x. So now for the second derivative, well, I'm going to use the product rule here. This can be my u, and this can be my v. Then u dash will be n cosh hyperbolic x, and v dash, just like we did for the first derivative, we're going to get n minus 1 cosh n minus 2x times by sine hyperbolic. So let me put that one first. Great, so then the second derivative, remember, is u dash v plus uv dash. So I'm going to get n cosh x for my u dash multiplied by v, which is cosh n minus 1x, plus uv dash, so that's n sine x, and then n minus 1 sine hyperbolic x cosh n minus 2x. I couldn't quite fit it all in. And we've got to tidy this up now. You can see in the final answer there's no sine hyperbolic x. Well, we're going to get n cosh to n x, because these two times together will get us back to that. And then I've got n minus 1 cosh n minus 2x, then sine hyperbolic squared x. Okay, gotta deal with this. Now remember, we've got, for trig, we've got sine squared plus cos squared is 1 for sine hyperbolic, and cos hyperbolic. Cos hyperbolic, it works in a similar sort of way, but you just change the this to a minus. This is Osborne's rule. When you have a sine squared in there, just with your normal trig identities, you basically just replace your sine squareds by minus sine squared. So now I can put h there and a h there, which means if when I rearrange it, this here is actually going to be cosh squared x minus 1. Okay, and let's write out one more time. This I'm going to expand this bracket, so I will get n cosh nx plus n minus 1 cosh. Now I'm going to do cosh to the n minus 2x times cosh squared x. That's going to give me an n here. And then I will get minus n minus 1 cosh n minus 2x. We're nearly there, and you can kind of just keep tabs on what we're actually trying to get to. In fact, let me just bring this down, because I think this is quite awkward. You might start questioning whether you've done it right and start looking back through it. We need to be getting an n squared. So, okay, let's multiply this bracket out. I'm going to get n squared cosh the nx. Right, so that is that term sorted. Then a minus n cosh the nx, which actually is going to cancel with this one. And then we've got minus n. And so it kind of just comes together and you sort of start looking at the final answer. And we're there. N squared cosh nx minus, don't expand that one. That is our second derivative, just in terms of cosh. Right, Now we're asked to determine an expression for the fourth derivative. It doesn't say we have to simplify it loads, and it turns out that you don't want to simplify it a lot for reasons that we'll see. Let's get into this. So, right, well, first of all, we're going to need the third derivative. But we can differentiate this, and because we've simplified it, we don't have lots of product rules or anything to do. It's going to be a similar sort of thing to before. So I'm going to differentiate. I'm going to get n cubed cosh to the n minus 1 x, then sine hyperbolic x, then minus n minus 1, n minus 2, cosh n minus 3x times by sine hyperbolic x. Okay, not much we can do with that. I think when I did it, I might have factorized out the sine hyperbolic. Um, I did, yeah. But I think in this situation, I'm not gonna. I'm gonna leave it like it is. So then the fourth derivative. Okay, and again, we're dealing with the product rule a few times. So I'm gonna get n cubed, n minus 1 cosh n minus 2 x times by sine hyperbolic x plus, actually I can fit it here, plus n cubed cosh to the nx, because it's going to be this times by the derivative of this, which is cosh. Then minus n minus 1, n minus 2, n minus 3, cosh to the n minus 4 sine hyperbolic x minus n minus 1, n minus 2. And now I've got this cosh n minus 3. I'm going to be times by the derivative of sine hyperbolic. So I'm going to get back to cosh n minus 2 x. And let's leave it like that, okay? It's absolutely fine. It's only a 2 marker, and it's mainly so we can then do the next part. All right, we're ready for the final part. We're asked to hence determine the first three non-zero terms in the Maclaurin series for y equals cosh x all to the power n, giving each coefficient in simplest form. So here we go. Here's our Maclaurin series. Now, key ideas here, because we're going to be subbing in 0, are that cosh 0 is actually equal to 1. Because remember, it's e to the x plus e to the minus x over 2. So it's just 1 plus 1 over 2. Whilst sine hyperbolic of 0 is 0. So let's work these things out. F of 0 is going to be cosh of 0 to the power of n. Well, that's just going to be 1. F dash 0, the first derivative. Now we worked it out here. Now because it's got sine hx in the product, doesn't matter what the rest of it is, we're going to get 0. And we're also going to get 0 for the third derivative, by the way. Whilst f double dash of 0, I can sub it into here. I'm going to get n squared minus n minus 1. Remember, these both just become 1, which is n squared minus n squared plus n. We just get n. Third derivative, as mentioned, is 0 again. This just leaves us the fourth derivative evaluated at 0. So all of these evaluated at 0. Okay, well, this is why we definitely don't want to simplify it. That term is going to disappear, as is that term. So we're just going to get n cubed minus n minus 1, n minus 2. And we're pretty much there. Just going to expand the bracket on this latter one. So I will get n times n squared minus 3n plus 2, or n cubed minus n cubed plus 3n squared minus 2n. So therefore, cosh x to the n is going to equal f of 0, which is 1. This term disappears. Then I'm going to get x squared over 2 times n. There's going to be no third derivative. So x cubed over 3 factorial times 0. But then I'll get x to the 4 over 4 factorial multiplied by 3n squared minus 2n. This gives 1 plus nx squared over 2 plus 3n squared minus 2n x to the 4 all over 24. That is our Maclaurin series. Magnificent.